In this video, let's understand how e-commerce platforms like Amazon and Flipkart avoid double charges to the customers in case of network failures during order payment. Imagine you're shopping online, adding items to your cart and making the order payment. Suddenly you find out that you have been charged multiple times for the same purchase. Annoying, isn't it? In a distributed system, often network failures can lead to multiple payment requests, causing frustration for both customers and businesses. And that's where Idempotency comes in. Hi there, welcome to Tech and Career Bytes. I'm a software professional with over 2 decades of experience, including 7 years in leadership roles at a global product based organization. To understand the impact of network failures, let's focus on the payment process on an e-commerce platform where the customer initiates the payment for their order. Initially, the customer submits a HTTP POST request through the payment API to the server. The e-commerce server receives this request, executes the necessary action, and promptly sends a response to the customer. However, if there is a network failure or timeout, the customer fails to receive a response from the e-commerce server and resubmits the same request. Upon receiving the duplicate request, the server executes the operation once more and responds accordingly. Despite this, the customer still does not receive the expected feedback and submits the same request for a third time. Following the final request, let's assume the customer eventually receives the feedback from the server. But if you have noticed, by this point, the server has processed the order payment 3 times. The system's reliability is compromised here as each duplicate request causes an extra payment, which goes against the customer desire for a single payment. One of the most critical challenges faced by the payment systems is the risk of double charging the customers. When designing such systems, ensuring that the payment orders are executed exactly once is very important. Now, the question arises, how can we ensure exactly once payment? Let's discuss that in detail. Initially, achieving exactly once execution might seem challenging. Let's break down the problem into two components for simplicity. Mathematically, an operation is considered executed exactly once if it satisfies the two conditions. It is executed at least once and it is executed at most once. Let's explore how to implement at least once and at most once for our example payment process. In some cases, retrying a payment transaction becomes necessary due to network errors or timeouts. Retry guarantees that an operation is executed at least once. For instance, consider a scenario where a client attempts to make a $10 payment, but due to a poor network connection, the payment fails repeatedly. Expecting a possible network improvement, the client tries again, finally succeeding on the third attempt. When retrying to ensure at least one execution, it is also important to guarantee that the operation is executed at most once and prevent duplicate operations. Now, let's discuss the implementation of at most once using idempotency check. Idempotency offers a solution to prevent duplicate operations. Idempotency ensures that even if an action is repeated multiple times, the result remains the same. This safeguards against the unintended consequences and ensures consistency in an e-commerce ecosystem. Let's understand idempotency with the help of a mathematical function f of x equal to x to the power of 5 plus 6. For the equation here, if x equal to 2, then f of x is equal to 38. The f of x value will not change as long as x remains 2. This means that the equation here is idempotent for x equal to 2. In the same way, an API, a method, or operation is idempotent if the response remains the same for all the identical incoming requests. From the example payment API perspective, idempotency ensures that the clients can repeatedly make the same call and consistently produce the same result. This helps us achieve the desired single payment even in case of duplicate payment requests. HTTP methods are commonly used within APIs to define the actions or operations that clients can perform on a resource. Making HTTP methods idempotent enables the idempotency attribute of the API, which eventually helps achieve reliability. The table here highlights the idempotency property of the various HTTP verbs. You can learn more about the various HTTP actions or verbs in our video. The link can be found in the description box. Most of the HTTP methods are already idempotent, so we don't need to make them explicitly idempotent. However, some of the methods, such as post and patch, are non-idempotent by nature, but they can be made idempotent. Let's discuss the side effects of identical HTTP post requests through an illustration. This will help us understand and appreciate the need for idempotency check. The illustration here shows that the client sends the post request to the server and the server stores the content in its database. When the client does not get a confirmation response from the server, it sends the same request to the server again. If the server has no strategy to deal with this, it executes the same request again and stores the same data in the database. Therefore, we can see that using a post to add data can lead to redundant data in the storage. In web and mobile applications involving client server communication, to handle the issue of redundant data storage, typically an idempotency key is employed. In these applications, the clients generate unique 128-bit identifiers, usually version 4 UUIDs, known as idempotency keys. These keys are included in the HTTP header of requests. When the server receives a client request, it saves the idempotency key along with the request in its database. If the client sends the same request again, the server checks its database using the idempotency key. If the request has been handled before, the server ignores it and sends back the previously saved result. Otherwise, it stores the idempotency key and processes the request. As shown in the illustration, we assumed that the client did not get a response from the server on the first request because of some network errors, but it got a response on the second request. UUID based idempotency keys are endorsed by major tech companies like PayPal and Stripe. This is how the idempotency key is packed with the HTTP request in the curl command. Before we get into the details, let me emphasize the importance of staying updated and continuously learning in the tech world. With new advancements and innovations emerging every day, it's crucial to keep honing our skills. Check the description box for some learning resources covering coding, system design, and advanced computer science concepts. Version 4 UUIDs offer unique random numbers, but storing millions of them in the server's database creates scalability and storage cost issues. To mitigate this, we can impose expiry time on the unique IDs on the server. As an example, consider a commercial bank server handling thousands of transactions per second. For HTTP methods like a post and patch, which require idempotency keys to efficiently manage the storage of these millions of keys, storing idempotency keys until the session ends is a viable solution. Sessions typically last from 1 minute to an hour but can be extended up to 24 hours. Assuming a user generates same transaction after a network error, the server can match the idempotency key and provide the cached responses. Once the sessions end, the server deletes all the keys associated with the sessions to free up the storage space. Users generate new keys for the subsequent sessions. Popular applications like Twitter and Instagram also adopt idempotent methods to enhance user experience by reducing the data redundancy and minimizing the resource load on databases. In conclusion, idempotency plays a crucial role in maintaining the system reliability and consistency. By implementing strategies like idempotency key and retry mechanisms, payment systems can mitigate the risks of double charging their customers and provide seamless customer experience. If you found this video helpful, give us a thumbs up and subscribe to our channel for more interesting tech topics. Also, do check out our other videos on software performance optimization case studies, system design, big data, coding, and career growth. My name is Rupa, and I thank you so much for watching this video. See you next time.